All right, everyone. Thanks for coming. This is the Ski IT SLURM presentation. As you guys know, we are getting in a lot of new resources, and we want to leverage them as best as possible, as well as bring ski more in line with how CHPC and other large HPC organizations do computing. So, to that tune, Chad has been heading up SLURM with some help from Lucas, and he has a presentation to get you guys jump started on it. So I will turn this over to Chad without further ado.
All right. Well, good morning, afternoon, ski people. For those of you that I've not met, my name is Chad. As Todd said, that I've been working with Slurm the last several months, January, December. I can't remember how long it's been. And working to get our infrastructure set up so that we can use Slurm here. The talk that I'm giving today is basically to get people jump started from what is SLURM to running their first jobs. And that should probably take, I'm going to say, maybe about 20 or 30 minutes if I speak directly without any stops. I've got 16 slides. But I'm also very happy to make this interactive. So if you have any questions, please just raise your hand. Lucas is going to be in charge of kind of watching the room and whacking me on the side of the head if there are any questions. Or if anybody's joining remotely, feel free to put it in the chat. We're going to be taking a look at that as well. And I'm happy to stop at any point and go into whatever depth or whatever questions people have. A couple of caveats before we get started. One, like I said, I'm not the world's greatest expert in Slurm. There's a bunch of stuff I don't know. It's actually quite a big topic, but I am very good at finding out answers. So if you do have any questions during this conversation or later on down the road, next week, next month, next year, just reach out to us and we'd be happy to do our best to help answer your questions. The second thing is I'm also, against all better judgment, going to be doing this as a live demo. If you can see my screen, I have a slide on the top and I have an open shell at the bottom, and I'm actually going to be typing commands into the ski infrastructure, running some jobs and so on and so forth. And I think now that I've said that out loud, that means everything's going to break and nothing will work. So let's find out and let's get started. So first off, if you're one of the people that I heard at the beginning that was accosted by Jake in the hallway and pulled in and said, hey, you want to learn about SLURM? What is SLURM, just to begin with? I think most people here at Ski are used to kind of an older paradigm where there are different machines within the department and users log into them to run their jobs. And this raises a number of issues. You have to know what machines are out there. Other people might be logging in and running their own jobs and consuming resources. There's lots of contention, and that job you thought would be finished overnight, when you wake up in the morning, it turns out that it's only halfway through because a bunch of other jobs got fired up and so on and so forth. SLURM, as any good software project, is meant to solve that problem, and that is the problem it's aimed at. It is a job scheduling chunk of software. So users submit jobs to SLURM, and SLURM figures out the best resources to run them on. So instead of knowing that, oh, I have to log into Atlas and I shouldn't be doing it on Thursdays because that's when Chad always runs his big jobs, you just go to SLURM and say like, hey, I need 10 CPUs and 2 GPUs and a whole, mess of RAM. Find the best resources for me. Or if those resources aren't available, schedule my job and get it running as soon as resources become available and let me know when it's done. This way, people aren't burdened with the idea of solving that problem in their head anytime they want to run a job, and we have better utilization of the resources that we have. So a couple of things just before we jump into things. Terminology is actually pretty important in SLURM. There's a lot of vocabulary that gets thrown around. In fact, yesterday in a meeting with Ski IT, we were stepping over cluster and partition and groups quite a bit, and it led to a little bit of confusion. So let's just kind of get that out of the way. In the SLURM world, a job is just any workload that needs resources in order to run. You're going to submit a job to SLURM. SLURM will get it to run. That's your job. Within that job, there might be many steps or tasks. Those could be iterative, they could be in parallel. And those tasks are assigned to compute nodes, machines out there that have resources that can satisfy that job work. Those nodes are collected into partitions. So you could have a partition of, 1 to 1 million machines and say like, hey, I want to run my job on this partition, and that's the group of machines that will look for to satisfy your needs to run your job. Okay, here comes the fun part when we actually get interactive. How do you use that here at Ski? Well, it's actually pretty easy. There's just one node or one machine where you go to in order to run your jobs, and that is compute. So if you can see my bottom screen, I can just SSH into compute. It is just another Linux machine. I can, do normal Linuxy things on it. Like go to my SLURM presentation directory where I have certain files. Actually, remove my old logs. I think it's just a box that has specific SLURM commands on it that you can run. So, for example, you don't have to worry about these right now, but you could do, because we're going to talk about them in just a slide or two. But, I can run SQ to see what jobs are being run right now across all of the resources here at Ski. SInfo shows information about nodes. Like I said, I'll talk about these in a little bit more in a second. But before we get there, let's talk about the resources that we do have here at Ski, the partitions per se. There are two that are provided by Ski IT for general usage. One is called Wormulon. That's going to be the one that we're going to be used today. That's a cluster of small virtual machines. They don't have a lot of RAM or CPU power. There is one GPU in the Wormulon GPU partition. But they're there for people to play around with, to learn SLURM, to debug, or do anything else like that. It's really just a playground for people to use. There's also our new Spartacus partition. Those have been in place a few weeks now. We have 3 machines, each of which have 8 GPUs in them, 750 gigs of RAM, yada, yada, yada. And Todd, we just got our GPU machines in a couple of days ago. Can you, off the top of your head, tell you what the specs are on those?
CPU, we got in 6 AMD, they're 9755, so 256 core and 1.5 terabytes of memory off the top of my head. It's been a while since we ordered them. Then they will be pretty much, we have 2 that are reserved by KEG, I believe. So they'll have priority on those once we get that all worked out. But the other ones will be available for general use. And we should have those in production by next week, I would imagine.
Yeah. So a fair bit of horsepower. Let's see, ding, ding, ding. So let's get into some of the basics and figure out how you can find out what machines and what resources are there. The first command is just called sinfo. All the SLURM commands begin with an S. So sinfo is information about what's going on in SLURM world. So if I type sinfo, if you can see on the bottom, you can see it shows me what partitions are there, what kind of state it's in, that there's computational resources available. The time limit shows a maximum length that jobs can run on a particular partition. What individual machines go in there and what's going on right now. Like some jobs are running, but there's still some capacity. Zagreus is totally idle right now, and so on and so forth. Like all SLURM commands, there are tons of options. So you can customize the output however you want. You can look at just individual partitions. Here's our partition called Wormulon CPU. You can see that there are 3 computers in it, Wormulon 1, Wormulon 2, and Wormulon 3. They're idle right now, which is great for our demo, so on and so forth. One kind of very interesting flag is sinfo -r. And if I were braver, I would have taken a machine out of rotation and broken it in some way. But if a machine is not available for a particular reason, like it's being patched, it's got some sort of problem, it's crashed or whatever, you'll be able to see the reason listed here and get an understanding of why it's not available. As another example, I use this one all the time. I just have an alias in my shell set up for it. You can see all sorts of information about machines, each machine, what partition it's in, how many sockets, cores per socket, threads per core it has, the memory, and so on and so forth. The man page for SBatch is about 50 pages long. I'm sure you're going to have a fun time reading through it and finding all the different options. But it's a great place to get started just to know kind of a quick glance of what the state of the world is. The next one is SQ. This shows jobs that are currently running or waiting to run. So if I run it, a very big thank you to Jake for having a job that is pending resources right now. So you can, this is a great example of why SLURM is kind of slick. Jake has submitted a couple of jobs, one of which whatever he's asking for isn't available. So SLURM is just holding on to that job. And as soon as those resources become available, the job will be scheduled, it will run, and then he'll get his results out of that. So he doesn't have to sit around twiddling his thumbs and waiting for things to show up. But you can also see, yes, go ahead, sorry.
That specific job that I have, there's actually 6 of them queued up because I used an array.
Yeah. Yes, sorry, there you go. Yeah. So 1 and 2 are running, 3 through 9 are still waiting to go. Right on. Like sinfo and all other SLURM commands, there are tons of options depending on what kind of information you want to see. You can look at them, just, you know, see your own jobs. Show mine. I don't have any jobs that are running right now. You can format things. This is, again, one of the aliases I have in my shell that shows a lot of information about the particular nodes. Jobs that are, you know, an estimate of how much time left is going to be given there. It's not a guarantee, but it's a guess given how things are going. So yeah, again, another 50-page man page that will put you to sleep when you lovingly read over it tonight. The most important command to know is SBatch. SBatch is how you actually schedule a job within SLURM. And the general mechanism for that, although there are options, is to pass it basically a shell script. Bash is generally pretty popular, although I think you can use anything in particular. And you give it these little, I guess, preprocessor directives to tell SBatch the types of resources you need, or what the name of your job should be, or where to write log files and those types of things. So in this very simple example, you can see I just have a couple of commands. It's going to echo whatever host name I'm running on. It's going to give the start time, and then I have this little Python script that I wrote called fib, right? G533 that calculates Fibonacci, and then it's going to sleep for 10 seconds and then print out the time in the end. So that is right here as example SBatch. And if I want to run this through SLURM, I just run SBatch and I give it this command. And you can see that I now have a job that's running. And if I check the queue for my jobs, I have a job. And that job ID is 3667. And boop, 10 seconds went by. The job has finished, and it wrote out this log file that has the output of my command. And there it is. You can see that it was, the host name was Wormulon1. I am actually on compute, but it's the job. I said, hey, I wanted one node. It picked Wormulon1 because that was free. The job started at this particular time. My little random number generator here picked 78. I calculated the 78th Fibonacci number. It's that thing, and then spit out the end. Ta-da! I just ran a job in SLURM. Easy peasy. Any questions so far? Or is this, I haven't. No.
I have one.
Yes, please.
Do I always have to be logging into like compute.ski.utah, or can you go onto like Shell or Bunny or whatever you're at?
Just compute.
Okay.
That's the kind of the entry point for all of these things.
The compute has the whole ski file system mounted to it, right?
Correct. It's just, it is exactly identical to Shell. It just has the SLURM stuff too. So, right on. So SBatch has tons of different options to them. Just a couple I wanted to highlight. You can have your script send you email at different steps along the way so that you can start your job and then go to a movie or, go outside and see the sun or whatever, and get email whenever your job is complete. Like I said, those directives also can tell you, how many resources you need. I need 2 different nodes to run on, or I need a GPU. We'll talk about this a little bit more in a second. I need 500 megabytes of memory for each CPU that I'm asking for, or those types of things. So again, like the documentation is going to be your friend here, as is the internet, because there's tons of pages and stuff like that out there about this. So how do we run multiple jobs? Well, there are a couple of different ways of doing this. The one that Jake just mentioned before, he had that 9 different jobs that were all running. One way you can do that is by using the array argument. That's right here in my preprocessor directives. This is basically saying like, hey, I want my job to run 3 different times because I'm giving it 3 different indexes, 0, 1, and 2. Each one of those is going to get 1 CPU for this task, a certain amount of memory, yada, yada, yada. And in this case, you can see it, this line right here is a little different. I'm now using this thing called srun. Srun is a SLURM command that's going to basically take a command to run, and it's going to run it as many as it needs to fill out your number of tasks. So for here, like I said up here with the array, I'm asking for 3 different tasks. So srun, even though I'm calling it once, should run 3 times. So let's see what happens here. This is SBatch. Just to show you, example, srun 1. It is the same code where I calculate 3 different random numbers and then pass each one of those into my node fib command, which is just node fib, that part of my previous script that I've taken out. Does that make sense? I've just taken my script out, made it its own script, and I'm calling it 3 different times with 3 different random numbers. So let's submit it to SLURM. srun. This is 2, 1. So I now have my job, SQ minus. Let me see my jobs. I have 3 different jobs, very much just like Jake's. I have 3. They were each running 4 seconds when I ran that. 10 seconds went by really quickly. And now I have 3 different outputs, 1 log file for each of the jobs that I ran. So if I take a look at 68, there's my output. My ID of those 3 different indexes, 0, 1, and 2. This one actually was 2. It was running on Wormulon 1, and it calculated the 95th Fibonacci and then slept for 10 seconds and did its thing. If I look at the second one, this is the one that belonged to the 0th task ID, and it calculated the Fibonacci, the 80th Fibonacci. And then job 70 was task ID 1, which calculated the fib of 20. So I did 3 things all at once with this one simple script. Another way in which you can do this is by specifically saying, hey, I want a number of tasks. In this case, I'm asking for 3 different tasks using the end tasks argument. And I want it to run on 2 different nodes. So 2 different computers. For whatever reason, I want my Fibonacci's to run on 2 different ones. And so down here, you can see I'm calling srun. I'm again calling my Fibonacci script, which prints out the host name and so on and so forth. And I'm passing it in a random number. So let's see what happens when I run. So I've got my job submitted. And if I look, I have 1 job. This time it's just one job ID. Ran for 5 seconds. It is now done. It was 3672. Let's take a look at that. This is the output from the file. It's a bit of a mess. You can see all 3 different tasks were spitting out into this file at once. One job was running on Wormulon 1. A second job was running on Wormulon 1. Another one was running on Wormulon 2. The start times are interleaved. And they all calculated the Fibonacci of 88. Why is that? Why is this any different? Well, if you look at the SLURM script up here, this is the command that's saying like, hey, I want to run something 3 times. So what does it do? It says, well, this is the command I want to run, and this is an argument I want to give to it. So it calculates a random number. In this case, it was 88. And then it said run node fib.sh with the argument 88 3 times, which is what we got. A bit of a mess. So how do we fix this so that we can actually get the kind of output that we like? This is what you would do. Again, all of this is the same up here at top. I'm saying I want 3 tasks. I want them to run on 2 different nodes. But srun takes all the same arguments that sbatch does. So I can say, hey, I want you to fire off a task, 1 task, just so run one thing once on one particular node. And I want that task to be echo hostname and run my thing with a random number. And then do that again and do that again. These will all run in parallel, but I'm being more deliberate about saying what I want to run for each particular task. Does that make sense? I will take the silence as yes. So let's go ahead and run a 3rd.
So Chad, I don't know if you're going to talk about this or not, so I might be jumping ahead of you, but
No, please.
also put the array number into your log file, like using the %a operator when you're specifying the array file or the output file name, so that they all output to different files.
Yes, you could certainly do that here. There are a number of different.
Yeah, like there's a different way to do it. Like there's like 6 ways to do everything in SLURM.
Exactly. Yes, that is probably the biggest takeaway for SLURM, right? There are always a million ways to do that. So what was my job? Was 3673. There's my job. So I got very much a similar output, but you can see that each job ran on its own and got its own number. Make sense? Okay, sounds good. Now that's all well and good. One common thing that a lot of people mention is like, how do I debug, right? Or how do I work with things in the way that I'm used to, where I have a terminal and I can run something or cancel it, start over again, and so on and so forth. That's harder to do when you just throw in a batch job and wait for the system to do its thing. Well, you can say like, hey, I want to schedule a job and I want that job to be interactive. I want a shell on that, right? And you can do that by just calling srun directly from the command line. This is a command that says like, hey, for 5 minutes on the Wormulon CPU, I want 1 machine with 1 task and I want it to be running bash, right? So if I just copy and paste this, blink, here I am, I'm on Wormulon 1 and I can do, whatever I want. I can run fib of, 33 again or whatever, right? This is a job, it's scheduled in SLURM. I have a job running. It is bash and I can do things with it. I can run my Python code. I could, debug something or do whatever. The thing here is that by running it through SLURM, the resources that you're asked for are yours and yours exclusively, right? So SLURM can know how to schedule other jobs around it and so on and so forth. That job will keep running until the time that I've said is going to be my endpoint, or I can just exit the shell and boom, my job is done. So while we're here, I'll also talk about GPUs a little bit. The way that you ask for GPUs, like in what we saw in SBatch before, you can ask for different nodes or different tasks or different memory per CPU or CPUs per task. And like there are infinite varieties that are there. For GPUs, you ask for them using this command, using gress. This is a little bit of an unwieldy syntax. It stands for generic resource. Doesn't matter. The only generic resource we have here at Ski is CPUs. So this flag here is basically saying like, hey, I want a GPU resource and I want one of them. Or here it says I want a GPU and I want two of them. So for example, if I take this, I'm going to run this on the SEG GPU because there are a number of GPUs there. So I'm on Zagreus. If I run NV top, do this, rank. You can see I have one CPU. It is GPU 0. It doesn't necessarily mean it's the 0th GPU on the machine. When you ask for different GPUs, you always start from 0. So if let's say if I ask for 2, so I'm going to run the same thing, but asking for 2 GPUs this time. I run NV top. I now have 2 GPUs, 0 and 1. You could do the same thing in an SBatch. Like I said, all these arguments kind of go for either way that you want to call jobs. So, I guess one thing I forgot to mention. Yeah, I'll show you here is when I was talking before about interactive jobs, right? So if I want to run this thing and say like, hey, I want to grab a shell on one of the nodes in Wormulon GPU, I said one of the benefits of using this rather than logging into the machine directly is that my resources are exclusively allocated to me and they're not going to be used for another job. And SLURM knows how many resources are left over for everybody else's job, right? So if I'm sitting here chewing things up, I have my own little playground and SLURM can manage all of those things. One very common way of setting SLURM up and the way we have it set up here at Ski is we don't allow direct SSH access into these compute nodes. Because then people can SSH in, they can fire up a big job, they can consume a CPU. SLURM is completely unaware of it. It doesn't know how to schedule things. And you're back to that, you need context and you need to hunt and find the right place for things. So you can schedule interactive jobs. But one other thing that we've set up here is a restricted shell on nodes. So you can actually SSH into a box and do diagnostics. It's restricted in the sense that there's a certain number of commands that you can run. So you can't just, fire up your giant Python environment or whatever else like that. But if you try to SSH into, let's say, Wormulon 3, which is one of our SLURM nodes directly, this stage 3. Blink, you can see that, hey, it tells you right off the bat, this is a restricted shell. There are only a certain number of commands you can run. So I could run top, for example. I could do ps, for example, but I couldn't run, let's say, Tulsi Lake doc SLURM presentation fib.py of 34. Sorry, you can't do that. So that way, if you have a job and it's running on, Zagreus or whatever, and you want to get in, you want to run NVTop, and you didn't have an interactive job or anything else like that, you can still do that. You just can't run heavily interactive things. Okay. So what's next? This is a good starting point for Ski in the sense that we have an environment. It's functional. People can schedule and are using jobs right now, but there's still quite a bit of work that we want to do. As Todd mentioned, we do have a new CPU cluster that just arrived a couple of days ago. We're going to install and get that up and running for you guys next week. One thing I didn't talk about much here, and by not much, I mean zero, is how accounting and access management works. My hope is that it's mostly transparent to you guys, but I also have learned a lot over the last couple of months and want to basically overhaul and re-architect how that all works. That'll all be behind the scenes, and like I said, I hope it'll all be transparent to you guys. But it is a prerequisite for setting up preemption and prioritization. So one of the principles we've wanted to follow here in Ski is that by utilizing SLURM, all of the resources that are available at Ski should be used or be available for use when they're idle. That said, there are certain research groups that have bought their own resources, and so they should have, first access to those particular boxes. And so there's a whole mess of ways in which you can say like, hey, like, if this person is in this group, have their jobs preempt other jobs and so on and so forth. That's quite complicated. And I want to get the accounting rebuilt before we get into that. But once that is done, it should be a lot easier for people to find available resources, and we'll do a better job of using our resources to their full potential. Todd's already been, as a next project, Todd's already been working on getting some monitoring and graphing so you can look at all of the compute resources in Ski in one handy dandy place and see kind of what's going on with them. We also want to set up and make it easier for people to know what Scratch disk space is available for them on the host that they're running on or in a shared Scratch space, and have those automatically, some areas automatically set up for you to use when you fire up a job. And lastly, there are certain capabilities we'd like to hand over to POCs in any particular resource groups to say things like, hey, I want to set up a reservation for a certain amount of compute at this particular day or time, or I want to give this person access to these special resources or stuff like that. So we want to build the infrastructure that'll kind of hand that capabilities over to the research groups themselves, and so that Ski IT doesn't become a choke point you need to ask for those types of things. And lastly, how do you find more information? Because literally this is scratching the tip of a very big iceberg. We do have our own SLURM documentation. I added some stuff yesterday. I'll continue to add to stuff that's there. There's the SLURM documentation is at SkedMD. That's the company that actually writes and maintains SLURM. There's tons and tons of stuff there, architecture, all the man pages, examples, and so on and so forth. CHPC has been running SLURM for 600 million years. They have tons of information up on their website. They actually have a YouTube channel with a bunch of videos about how to use SLURM. They also teach a class, I think once a semester. So yeah, they have a lot of resources as well. We do have a Slack channel, SLURM users, that should be plural. And then obviously there's tons and tons of misinformation and good information out there online. Google, YouTube, Reddit. There's probably not much on Instagram, but if you find a good IG post about SLURM, please let me know. That would be kind of interesting to see. And that is slide 16 of 16. So I think I was pretty much almost spot on 30 minutes. So with that, any questions, comments, good puns that people would like to share?
Does anybody have any questions?
I have a question, which is,
Here.
yeah, so does it matter which like MPI implementation I use? Like
OpenMPI or MPitch, or does it just work with any of them?
It will work with any of them. It basically is just a how to get resources assigned to a task. So yeah, both of those I haven't used them personally. I haven't used MPI in forever, but there's certainly plenty of examples online about how to do that.
And I will say from my experience with MPI, especially from CHPC to here, right? I know CHPC has their infrastructure like well set up with their InfiniBand backend and whatnot, like all their nodes can see each other very easily at high speed. I don't know how well, like if you've used it already on your, if you know how to set up appropriately on your compute nodes, then it should work how you expect it to do. And it's just using SLURM as the resource allocation tool. Todd probably has a better idea of that.
Yeah. So two comments on that. One is CHPC is moving away from InfiniBand because it's expensive and you need dedicated Mellanox switches and all that kind of stuff. And the NICs themselves are more expensive and they can reallocate that money to buy more nodes. So moving forward, they're going to be using converged Ethernet, which is also what SKI has settled on. So we'll have 100 gigabits. Technically, we have 2 so that all of our switches are, I mean, all of our nodes are redundant to 2 different switches. So you'll have an aggregate of 200 gigabits to every compute node, which should be sufficient for both NFS and the internode communications. I was also going to comment on the scratch space. As we're trying to get away from like, you can imagine if you load a data set on Spartacus 2, that means all your jobs have to run on Spartacus 2. So one of the things we're looking at is the cache FS file system, which works with NFS, and it will automatically look at the files that you use and pull them into local NVMe scratch for you. And then obviously that will eventually fill up, and then, you know, the oldest files will get cycled out. We need to work with you guys for that because we need to understand your data flows. We've been talking to IT liaisons. It would appear that primarily you guys are read-only based, which is good because that's a limitation of NFS. If you do have a, not that you don't ever write, because obviously you have to write your results out, but if most of your access is read-only, where you are accessing the same file over and over and over to do your computation, that will work great. But if anyone does have something that is very write-heavy, where you're writing out a lot of files, let us know because we would have to move to NFS version 4, which is our long-term plan anyway. But there are different performance trade-offs in doing that. Any other questions? Anybody online too, if you want to speak up, just raise your hand and we'll call on you.
Yeah, you should be able to unmute yourself. The other thing too is I think ostensibly when we put out the call for this, we said if anybody wanted to workshop their own SLURM stuff, I mean, you could hop on the Zoom call and we could put it up and go through it if you have really specific technical questions or.
Not as of yet, but I think eventually.
Okay. One thing I'll add to Chad gave a good bare bones overview of how to get started. And like he said, there's tons of documentation and CHPC, especially for things like, you know, we have a pretty heterogeneous resource pool. It's becoming less so as we buy big chunks of homogeneous machines, but especially if you're using the older infrastructure, it's pretty heterogeneous as far as, you know, what's there. And SLURM is actually pretty good at giving you full control of like saying, okay, when I ask for a GPU, I specifically want one that has at least 20 gigs of RAM, or I want one of this class or something. And you can use logical operations. It's like, I want this or that, or this and that, or, and it allows you to do that with pretty much most of its reservation stuff. I will say you can easily over constrain it, which is less of a problem here at SKI just because we have fewer users, but if you do start to transition to CHPC, which we encourage people to look into because they have a lot more resource, it is worthwhile to, you know, go over your SLURM submission scripts with someone. We just ran into this with our group where we were submitting them in a way that meant we ate up our allocation really quickly just because we weren't, you know, being quite so smart about how we actually requested allocation. And it was also taking forever for our jobs to start and things like that. As more people get on board, I think we'll start to see more of that contention. So far, it's like, you know, there's only a few of us actually using SLURM, but as we transition all the machines to it, we'll probably, you know, need to have more of these conversations.
And that is utilization and stats are something I was going to touch on a little more too. The site is stats.ski.utah.edu:3000. Don't ask me why Grafana loves to use :3000 and makes it a pain to and Jake's brought it up. So we do have a bunch of dashboards on here. I'm assuming you brought up the SLURM one. So you can get individual node information from the node exporter. This will gives you basic like CPU utilization, IO, network traffic, all the kind of like system statistics that you would normally get. And then we also, and yeah, you can scroll down and I mean, there's just insane amounts of information if you want it. And these are getting collected, I believe, every 15 seconds. That's one of the kind of beauties of a real-time series database, is it is pretty lightweight, and we can collect much more frequently than like traditional SNMP systems where you would poll every minute or every 5 minutes. If you want to go back, then you can do the GPUs. This is under construction. I'm still working on getting the GPU index number instead of the unique identifier, which is not super helpful. If people would stop hacking into stuff, I would actually have that done, but the world is what it is. And that's another thing I wanted to touch on. But if you could go through all the dashboards, you'll log into this with your normal ski username and password. It's tied into our LDAP. It is still a work in progress. Whenever I have these cycles with motivated on the is kind of when I have time for this, but it is pretty useful as it is right now. But just be aware, I may have to restart the server, or there may be things that are slightly broken at times because this is our dev and production site. We wanted to get this as early as possible, which ties into my next point, is that we really want to see our resources being used. We all have budgets, and a lot of this is being purchased with RAI money, which we have to share with the university. So it's hard to justify buying more resources if, like when Chad showed this, if you have like 80% of your nodes idle. So we're really hoping that you guys will adopt this and start using it and keep these busy, because that gives me what I need to go to Manish and justify that we need more computing resources. But if we see that we're only 20% allocated, then there's no need to buy additional systems. We have to be good players on campus and let other people avail themselves of the RA money where it needs to go. Any additional questions?
In terms of so in terms of memory allocation, is there a way to say you haven't ran this job before and you're not sure how much RAM it's going to take up? Is there a way to let it take up however much it needs to, as long as it's not like an insane amount?
No, because you have to specify when you submit the job. Now, what you can do, what Chad showed, is you can log into there and run top. And long term, there are tools for SLURM where it will show like, hey, this person requested 800 megabytes and they used 200 megabytes. Flag that so that we can let you know that you've requested too much. So, but in the meantime, what I would do is run your job, estimate on the high side so it doesn't get killed, but not crazily, and then log into the node and run top, and that will show you your memory usage, and you can see if you over allocated by too much. Then you can start trimming that down.
Cool. That sounds good. Thank you.
There's also it has tools for you can do memory at a flat amount, you can do it per core, you can do
Oh, I don't know.
Sweet.
All right, if there are no more questions, I first want to thank Chad for all the work he's put into this. It has been insane. It's SLURM is, you would think for being used by most of the world, it would be easier to set up, but it is non-trivial.
It's a classic piece of software, right? Where the code itself actually runs really well and it's pretty rock solid. And the same people who wrote the code wrote the documentation and did all of the user interface design. So it's great code and a little gnarly to wrangle with.
I'd also like to give a shout out to CHPC. As Chad said, they have a lot of experience with this, and specifically Brian Haymore. We formed a Slack channel with him, and he was indispensable for helping us every time we got stuck, or asking them, because there's a lot of design decisions. There's no right or wrong. You need to tailor it to your community, and he was incredibly helpful with getting us up to speed pretty quickly.
Yeah. And Jake and Jacob for helping us test and get things going as we rolled out. And that's, you know, one thing I'd like to kind of make sure I hammer home before we call it, is that this is a journey we're all on together. So please join us in SLURM users in the Slack channel. I'll put my slides and code up there if people want to play around with it. It's just in text files. It's in Markdown, so it should be easy to copy and paste if you want to run stuff or modify it. And if you do have any questions, just bring them up there, and we can all kind of grow this SLURM environment together.
I'll say one thing that I hope that getting onto SLURM will help us move away from is the, single, like targeting specific compute resources. Like the eventual hopeful goal is you just say, I have a job, I don't care where it runs, it needs to have these parameters, and you can just submit it with a big blanket of, either put it here or I don't want it to be preempted, so only put it on general nodes or things like that. But hopefully in the long run, hopefully it simplifies the use of the compute resources rather than having to cherry pick and figure out which machine does my software actually work on and has the right resources and isn't being used, et cetera. This should hopefully, once we get it all set up, make those problems less, constant.
And as Chad and Jake pointed out, we're a small community. I'm 100 feet down the hall from just about anyone, and we're in this together. And I'd like to think we're pretty responsive. So like if you're like, oh, that thing just doesn't work for me, we need to make this change, bring it up with us. We'll listen, and we'll do what we can to tailor it to our environment and your needs.
And thanks for coming, everybody. Grab a slice on the way out.
All right, can we give a round of applause to
Yeah,
Chad?
thank you.
Thank you.
Good.